Welcome here to the second keynote at ArangoDB Summit. We will look into what we actually mean by graph done right and how this is the underpinning of our Arango graph platform. For that, we will look into some of the themes we have seen in the first keynote this morning and, for example, revisit how graph can actually lead to unique insights into your data sets, but also where are the challenges in converting that into business value. One of the key cornerstones of creating business value out of your connected data, in my opinion, is a cloud. So this is we will learn a little bit about how cloud can actually help you to turn connected data into business value. Last but not least, my favorite topic, graph machine learning, which I would actually claim is one of the next levels in artificial intelligence. And we will see how all of this fits together into the concept of graph done right. And slightly different view onto this agenda is, especially if you've listened to the first keynote this morning or you've listened to our CEO Shaker for the past months, are his favorite keywords. So for example, graph first, cloud first, graph databases, graph machine learning. We've been hearing that for the past months. And in this keynote, we will dive a little deeper and try to understand what is actually meant by all those different keywords. Me, that is Jörg. I'm CTO here at ArangoDB, so responsible for all the technical stuff, in particular the core database team, the managed service team behind the cloud, and then also our machine learning team. So basically all of those themes we've seen on the earlier slide here. I'm particularly excited about this keynote because it combines all the different things I'm passionate about, and those are really database systems, large-scale distributed systems, and also this cloud-native world, basically bringing that to operational scale. Let's directly dive into the first question. Why should you care about graph? What is the value proposition behind graph? So I often get asked this question, when should I use a SQL database, or also called relational database? When should I use a graph database? And so for me, SQL databases, they are really great tools which have been around for a long time. But to answer that question, I would really look at my data access pattern. So SQL databases, they are great if my access pattern is kind of following one of two dimensions, either on the row level where we insert individual records. So for example, here, like always adding individual products, or in the other dimension, if we are aggregating over certain columns. So for example, here, if we wanted to answer the question, what is the average price out there? Maybe just as a quick side note, those SQL databases, they are also called relational databases. So you might think they're actually really great at relations because it's in the name. But when we talk about that, this is actually a 70s definition of relationships when we still measure it, mean memory in kilobytes. This is now where graph databases really come in handy if we really want to model out and query about the relationships in between different items. So for example, if we don't want to look at an individual product, but look at which products were bought together, so the co-purchasing pattern. And this is where graph databases make your life so much easier because they are turning those relationships into first-class citizens of the database. And that is enabling a lot of other things in turn. So for example, just expressing your queries much more naturally compared to SQL. If you have ever written some recursive joins in SQL, you probably know what I'm talking about, but actually just writing that as a graph traversal becomes much, much easier. Furthermore, while we're talking about joins don't really scale. If you look at database research, it's been pretty much a problem for the last decades. How can we actually scale joins? And this is in particular, if you want to query such patterns over large graphs, you really run into optimization problems with large number of joins out there. Last thing, this comes back to us as humans. We humans are actually really great in picking up and understanding graphs. So if we talk about the output, the outcome of some analytics, and you can represent it as a graph, it is much, much simpler for a human to pick that up and understand it. Whereas if it's kind of like in a relational format, you actually have to read through. So it actually also helps us to capture the outputs much more naturally. Same or similar aspects actually apply if we talk about machine learning. In traditional machine learning, we often consider individual items as the input to our machine learning task. So here, if we are talking about our products, each product would kind of be the input to our machine learning task. And there's often also the assumption of independent and identically distributed data. This means really like each record, each product is viewed independently from all the other products. Just in most real-world cases, this is actually not true. So let us revisit the co-purchasing pattern we have been talking about before. This actually creates a relationship in between different products, so they are obviously not independent of each other anymore. And this is the case for most real-world data sets, which are not independent but are highly connected. So just to have some examples, for example, supply chains, you can view it as a graph. The social interactions, social network, product purchasing patterns we've seen here, but then also in healthcare, fraud detection, anomaly detection, etc. We actually deal with connected data sets in the real world. And when we are going with this traditional route of machine learning, we are just ignoring this dimensionality of the data, the relationships, the structure in between individual records. So, sounds all great, but where's our challenge here? So, why can't we create business value out of our graph data? So, it is still challenging today for multiple reasons. First and foremost is probably that graph by itself, while being very vital and very crucial to those unique insights, it by itself is not sufficient. So we need additional capabilities such as search, analytics, machine learning to actually create value out of it. Next is the integration into existing architectures. Again, graph by itself is vital, but not sufficient by itself. So it usually lives in a larger ecosystem of different tools. And there it's often quite expensive to transform it into the particular graph format and then also transform it back into the normal format as soon as I have results out there. So that is typically like a quite expensive integration. Last point here is the enterprise scale. So graph analytics compared to many other tools is still like a fairly new, we'll talk about like the last 10 years, but compared to a lot of other tools, it's fairly new. So there are still many tools, many solutions don't scale to the data size you need to create value out of it. So we see that fairly often. People are coming over, either users from our open source community or enterprise customers who are like, we tried out a particular other solution. It worked great for the POC where we had a small sample data set. But then once we turned to our production data set and really needed to scale that out, we actually hit a lot of scalability limits. So in particular, I would claim that to get value out of graph, you need to go beyond a single server out there. And having said that, this also means not just I have to go in and manually shard it, manually divide my data set between different servers, but actually have that solution take that transparently, do that transparently for me. So the next big topic, which might not concern your data scientists so much or your data experts, but actually your operations team, is the fact that with almost any data solution, we are still dealing with a distributed stateful system. And that by itself usually is pretty hard. When I'm then moving into some kind of cloud environment where the infrastructure itself is still dynamic on top of that, then it becomes even more challenging. So kind of like operating such kind of data system is still a challenge nowadays. So here just on the right, was an internal slide. We had like a day of life in our operations team. So you can just see kind of the complexities they are dealing with on a daily basis. And just from a user value perspective, the things I would ask you to think about are, for example, security, high availability. How do you deal with upgrades? Because again, you're not just dealing with a distributed system, but a stateful distributed system you want to have available during the upgrade. The underlying infrastructure, the entire monitoring, networking is also, I don't want to call it a nightmare, but it's at least challenging out there. And then if you're dealing with end users, of course, you also have to support them. And to kind of, solve those challenges, we actually believe graph needs to be done right to create business value out of it. So if I had to kind of summarize my answer to that into like one single phrase, I would call that usability at scale. To get value out of graph, it needs to be usable at scale. And I think there our ArangoDB 3.10 release is a great example of that. So first of all, we are covering usability with a new feature called Enterprise Graph. This allows you seamless scalability of your graph data across multiple servers without having to know anything about sharding, distribution, etc. The next topic is that integration into larger ecosystems, especially with other capabilities. So there we always had Arango Search around. Arango Search is not just a full text search, but actually a full class information retrieval suite. And here in 3.10, we introduce even a tighter collaboration with the overall graph capabilities by introducing an inverted index. Next is then our analytics stack. So here we introduced a new capability in 3.10, read from followers, which allows you to separate your write workload to the cluster, potentially more your transactional workloads from your analytical workloads by having it run on different servers in your cluster. If you want to learn more about ArangoDB 3.10, listen later today to Claudio's talk on what's new in ArangoDB 3.10 to actually dive in all those details of that release. So, furthermore, talking about graph done right, for me it comes down to those two dimensions. First of all, there's kind of the core database itself, the core capabilities of the database. And I think there ArangoDB has some interesting concepts here. First of all, it's really built around scalable graph technology to really scale to a large enterprise-sized data sets. Furthermore, it also supports those other data models we've been talking about. And here, in particular, I would want to mention the document side. So in ArangoDB, everything is a document, a JSON document in the end, which enables you very easy import of data. Because in the end, like most tools, they support JSON in one form or the other, so you can easily plug it into existing architectures. Furthermore, it supports a number of what I would call advanced query capabilities, processing capabilities. We already mentioned Arango Search, the information retrieval, the full text capabilities, but also our analytics stack, our data science library, and our machine learning stack we will talk about in a bit. This is one aspect of just kind of the core data functionalities inside the database. I think the bigger picture for Graph Done Right is actually viewing it as an overall platform, which takes care and extends the ArangoDB itself by multiple dimensions. I think the first big dimension is taking care of the operational aspects. As we mentioned earlier, this is a distributed system out there with all its challenges in operating it. So that is being taken care of by the Arango Graph platform. The other is that inside a platform, you can actually combine additional capabilities, for example, for data loading, data visualization, key management, machine learning, for all the best practices of running ArangoDB and to create end-user value out of it. So all of that is basically combined with the best practices and best experience by the authors, by the main authors of ArangoDB itself. And therefore, we always have the best practices when running ArangoDB inside the Arango Graph platform. Okay, next kind of keyword on Shaker's list was cloud first. So let's see what's actually meant by that. We already talked a little bit about what are the challenges in running a distributed system. And so I think there cloud really helps us to solve that by offering a managed platform. And that managed platform, it comes with operations included. I put an asterisk here because obviously it's not like all the operations, but the core database operations, the core operations for the distributed systems, I obviously still have to take care of like some other application stack out there. But that is solving like most of the big challenges out there, covering high availability, security, maintenance, and overall best practices for running that kind of system. Next aspect is that platform is going beyond the core database itself. And this is really key to providing end user value out of there. I want to get my data in there as quickly as possible. I want to get results using machine learning out of my data and insights into my data as easily as possible. Next, a managed service is offering a large ton of flexibility out there. So first of all, I can run in different scenarios. I'm not tied to particular servers in some basement, but I can actually run across different cloud providers, for example. Next is scalability. As it's not my server hardware somewhere down there, if I need to scale up because it's, for example, Black Friday, Christmas holidays, etc., and my e-commerce site is really hitting up with traffic, I can easily scale up the system and thereby for a short time provide more capabilities than I would in other times of the year. Next, also again related to just provisioning of infrastructure, is just time to start. If I want to get started, I really just go to the cloud. I think it's a total of 5 clicks the last time I checked, and I have a running database out there. So it's really quick to get started. I don't have to talk to 3 different teams. I don't have to get permissions from probably 5 different people, but after 5 clicks, I basically have my system up and running. And that, of course, then also comes down to total cost. As I'm taking out people who need to look from it from an operational perspective, as also we as providers, obviously, again, running best practices, scaling that across large clusters, this really comes down to total cost of ownership, which goes typically down with such kind of managed service solution. I think most importantly for me, also running the engineering team at ArangoDB, it allows me to focus on my core business. I don't necessarily want to hire people who are really great in provisioning cloud infrastructure, for example. This is why we ourselves, for Arango Graph, we leverage the cloud platform providers ourselves, because again, it allows us to focus on our core business, and this is running the ArangoDB Graph platform best to create value for you. So, talked about Arango Graph quite a lot. What is it actually all about? So, Arango Graph was established about 4 years ago, and it's our fully managed platform to run ArangoDB and the additional capabilities around it. So, it comes from fully automated deployments towards monitoring and backup policies in the cloud, and then also to the scale up and scale out topics we talked about if you at certain points of the year actually are encountering more traffic than at other times. Overall, it's fully programmable, open API, so you can either go in through the UI or you can actually script everything yourself using Terraform, or also if you really want to go down and integrate that into your architecture, there are also HTTP APIs available you can hit up to basically control the entire platform. It's running across all these 3 big cloud providers, AWS, Google, and Azure. And this is also relevant if you have your existing infrastructure on those cloud providers already, because all of them offer capabilities right now to directly connect to our clusters. This is called private endpoints or private links. And that basically means your data never leaves the AWS network, never leaves the Google network, adding a big deal of security when running that. Down there, just some of our customers running on Arango Graph. I think this is already some quite big names, and this is something which gets us and especially the managed service team also quite proud to what they have built over the last years. Okay. Now, big question, that all sounds great, but how do I get my data in there? You might already have a cluster running somewhere, either on-prem in your own installation, or you might also be operating your ArangoDB cluster on some cloud provider. So basically, this is your production cluster, and now you want to migrate over to the managed service solution, but you cannot encounter any downtime. This is where we're really happy to introduce the Arango Graph Migration Agent, which enables you to have close to 0 downtime migrations into the cloud, into the managed service. And this is a quite handy solution because we wanted to encode best practices of migrating that. Keep in mind, still, while your cluster is, your original cluster is hitting live traffic, and then really reducing that downtime of basically switching a load balancer or switching your application over to point to the cloud instance. So close to zero downtime for your end user applications. Furthermore, as said, like encoding the best practices of such migration, such as security, it's fully encrypted. Ease of use, where we have a lot of pre-checks, where we early on check, hey, does it actually fit? Is it the best setup? And basically give you recommendations for running that out there. So how does it work? I mean, in short here, you can download the migration agent. You will then also see that pop up in the Arango Graph front end. What is the current progress of the migration, and then move over. If you are really interested, I would actually suggest to come over to our next session, that is Cloud Sync with ArangoDB, or into the cloud, where we'll dive into more details about that. Okay, next and finally my favorite topic, graph machine learning. So first and foremost, why should you care? Isn't that just like a fancy new term some of your data scientists are throwing around? It's actually more than that. If we look around what's happening in the ecosystem from big companies such as Google DeepMind, over Uber, LinkedIn, etc., a lot of them have dedicated teams for graph machine learning. If we look at research, if we look at the big machine learning conferences such as NeurIPS, if we look at a lot of publications out there with like breakthroughs in drug discovery, we actually see they are based on graph machine learning, or sometimes also graph analytic tools. And again, this comes down to the fact we can actually exploit relationships, and we don't leave out those relationships when doing our predictions and trying to analyze the data. If we look around the different use cases, as said, like a lot of large companies have dedicated teams for that. So for example, going over from the logistics sector, as said, DeepMind actually leverage graph machine learning to improve ETA predictions in Google Maps. Then we also see that a lot in supply chain use cases. Again, it could just be around delivery times, or it can also be about risk, like, hey, where's actually just analyzing, where's the risk in my supply chain, what should I fix, so single point of failure, etc., or similar things. Next big category is probably recommendation and search. So starting out with like the prime example, because I've written a really nice blog post about it, probably is Uber Eats, who's leveraging graph neural networks to predict when you use Uber Eats, like which restaurant to order from, and also potentially which meals to order next. And the other area where this is really powerful is in combination then with knowledge graphs, where we can do things like semantic search, or also other recommendation, and basically trying to infer more knowledge into our existing connected data. Next big area, and this is an area which actually has been driving this graph perspective for the last 10 years, while being not so prominent but still very influential, is computational chemistry. Like one real cool use case you might have seen last year, it was proposed by Google, which is about protein folding. So they actually open sourced a really powerful tool for researchers to predict protein folding, which is decreasing the time it needs to narrow down which structures you might want to explore further, by like from days in a wet lab towards just minutes on simulated networks. So this is obviously then very powerful if it comes down to drug discovery or trying to predict certain properties of molecules. And again, if you just think about molecules, in the end, they are graphs as well, certain atoms connected by bonds. And so again, this is another perspective where we try to either try to find similar molecules to something, and then also try to reason about the effect it might have on the human or some other chemicals. Last area is financial services, or overall also e-commerce, where we can leverage graph machine learning for fraud detection, credit scoring, or also to try to detect anomalies in general, for example, insider trading. Or we also have some use cases around, you will see tomorrow, around trying to detect brand infringement cases, where, for example, things are being offered on eBay, Amazon, etc., and someone tries to figure out whether this is now legit brand product or whether someone actually faked that brand. Okay, where are the challenges with that? So again, all sounds pretty nice, but why aren't more people using that? So why only those big companies with dedicated teams can benefit from it? And again, this comes down to probably first and foremost complexity of those new methods. If you think about the early days of neural networks, again, it was only really large teams and dedicated teams being able to benefit from it, where nowadays it has become a lot more mainstream. So if we look at what a GraphML expert trying to solve one of those problems has to look at, so here, this is one of the notebooks, Jupyter notebooks. We also have open source available, so if you really want to understand it, feel free to go to our site and have a look. But that comes down to over 2,000 lines of code just to solve like one recommendation problem. Furthermore, this is just using one simple algorithm. If you really want to be an expert there, you have to choose between different algorithms for different use cases, as they all have different properties. So just to mention some is, for example, which kind of graphs they can be applied to, whether it's a homogeneous graph where all the graph types, where all the node types are being the same, or to more complex graphs where we can actually have different types out there. Some of the other properties we'll cover in the talk tomorrow. We will dive deeper into that, but basically a lot of knowledge is required. Furthermore, even if we don't talk about GraphML in particular, that expert, just in general, graph data science is still pretty challenging. And it's not just referring to just a single data scientist, but it usually involves a large ecosystem around. So this is where I personally have seen a lot of projects fail, where people or data scientists, they really focus on like this small chunction here in the middle about the ML code. You code up a nice model. You can solve on some small scale some problems, but then you can't turn that into production value. You can't move that into business value out there because you're basically leaving out all this stuff around it. So probably like 80% of the time in developing machine learning solutions is spent not on coding a particular model, but is actually spent on the infrastructure, on the task around that. And this is why we are very happy to introduce Arango GraphML. This is our fully managed platform for GraphML. And our goal here is actually to cater different personas. So first of all, it's to make that a low barrier entry into GraphML. So that's why it's really follows a no-code or at least low-code approach, where you don't have to write much code. You don't have to understand all those models. You don't have to understand what is the best way of creating features for that. So data preparation is included, and really no expert knowledge for that is required. Still, we understand that there are experts around, and we want to support them as well. So if you have built your own graph machine learning model and just want to apply it to particular graphs, so basically just take care of the existing infrastructure around and focus on the small box we saw earlier in the middle, the GraphML part. Also, Arango GraphML is there to support you and basically take care of all the data hassling around that. We try to be very solution focused. So for example, providing simple tasks, providing value to end users from node classification. Just imagine like in your graph, you want to add a label to all the nodes. What is the churn risk of a particular person? Towards link prediction, we all have seen probably LinkedIn, Facebook telling us, hey, you should connect to that person, which is suggesting another link, another edge in your graph. It includes the entire MLOps from metrics, hyperparameter optimization, metadata tracking, monitoring, model management, etc., etc. Basically, again, enabling you to focus on the core part where you want to provide value. It's enterprise ready. It's built around the proven technology of ArangoDB. So we leverage a lot of the core technology of ArangoDB and basically just extend it by the machine learning part out there. This is also why we inherit the scalability. We also dropped in GPU support there to keep that scalability also for the machine learning part out here. And then also the entire security best practices are being transferred from ArangoDB itself to the platform out here. Here, this is just kind of like showcasing what are the different steps here. We go from selecting our graph, from featurization, basically selecting which parts of the graph do we care about, towards training a model, and then in the end to get value out of it, I need to apply it again to a graph or to kind of what's called inference in the field to actually get output from it. One more thing, or actually in this case, two more things, which we are also very happy to have around in that ecosystem, and the ecosystem is actually building the platform, is leveraging that internally, is a pretty extensive ecosystem of adapters for all your machine learning needs. So we internally, we actually use PyTorch Geometric, where again, there's another talk tomorrow from one of the creators of PyTorch Geometric. And on the other hand, if you want to leverage your own, for example, DGL, Deep Graph Library, or QGraph, from NVIDIA, we also have the adapters for you available to directly connect to these ecosystems. Furthermore, to accelerate the speed at which you can do that, at which you can explore your data, we have co-located Jupyter notebooks. Those are pretty useful tools. It basically allows you to co-locate and quickly prototype code within the platform and then basically directly connect to your database, so you don't have a limitation on through latency or throughput to get data outside from outside, because you're staying within the platform. Again, also that comes with full GPU support to give you the best and fastest track to innovation. If you want to learn more about that, again, talk tomorrow about next level graph machine learning. Feel free and make sure to drop in. In summary, so graph done right, one of the big themes in the title of this presentation, it actually allows you to turn your connected data into real business value. GraphML, then kind of as a next step on top, it really allows you to create unique insights you couldn't do before. And again, much faster than you could with traditional machine learning, because you take care of the structure of the data. Last but not least, cloud first, leveraging a managed platform enables you to have simplicity in your architecture and to really focus on your core task. So in short, this is actually what is our motivation for the Arango Graph Insights platform, to provide all of that to you and thereby accelerate your innovation. Thank you very much for listening. I hope there are some pointers for the next talks. Excited to see you there.